Next, we'll move on to the next sum. Find the voltage drop across 5 ohm resistor in the given circuit. So this is a 5 ohm resistor. In this 5 ohm resistor, what is the current? Sorry, what is the voltage drop? We need to find it out. So I have rewritten the circuit here again. Okay. So I have rewritten the circuit here again. And we have assumed the direction of the current which is flowing in the meshes to be in the clockwise direction. So let I1, I2 and I3 be the mesh currents which is flowing in the clockwise direction. And you can see from the mesh 2, there is a 5 amps which is flowing. Okay, so I can write I2 as equal to 5 amps directly. Then there is a I is equal to I2 minus I3. How we get this? You get this by applying a KCL at this point, Kirchhoff's current law. So incoming at this point is I2. Okay. Outgoing at this node is I3 and outgoing at this node is I1. So incoming is I2. So I can write incoming as equal to I2. So I will write incoming as equal to yes. So we have written incoming is I2. Okay, outgoing is I3 and I is outgoing. So incoming current I2, which is equal to outgoing current I3 plus I. So by rearranging this, what do you get? I is equal to I2 minus I3. So applying KVL to the mesh 1. So mesh 1 we get, we'll start with this. So minus 2I here, okay, minus 3. I1 we are going in the direction, there is a opposite I2 coming. So I1 minus I2 minus 5I1. So again, rearrange this. Okay, put the value of I, substitute the value of I from the equation number 2. Okay, you are substituting the value. Put values from equation 2. Okay, it is I2 minus I3 for small I. And then rearrange in terms of I1 and I3 and call this to be as equation number 3. Similarly, applying KVL to the mesh 3. Okay, 2I, here 2I minus 2I3. Okay, minus 2I3 minus 1. It is I3 minus I2. I3 minus I2. Okay, again you substitute the value of I here and then you simplify. And we also know the value of I2. So I2 values need to be substituted. And then there is only one variable now, which is I3. So from this equation, we get I3 to be 3 amps. So from the equation, so this I3 value we will put back in the equation number 3. And then we will get the value of I1, which is equal to 1.375 amps. So the current through the 5 ohm resistor, which is equal to I1, and we have found to be as 1.375 amps. So what is the voltage drop? According to the voltage drop, according to the Ohm's law, voltage across 5 ohm is current multiplied by 5 ohm. So the current is I1 multiplied by 5 will give me the value of voltage drop, which is across the 5 ohm resistor. So this completes the numerical. Next, we will move on to the next sum. Here they have asked you to find the value of I2 divided by I1. Okay, so I have written the circuit here. So there is a voltage V given in this circuit. And again, we are assuming the direction of the current to be I1 and I2 in the clockwise direction. So the current flowing here in the mesh 1 is I1 and the current flowing in the mesh 2 is I2. So here you need to find the direction. Sorry, here you need to find the ratio of I2 by I1. So I1 and I2 is mentioned in the question. So that is why we have assumed the same directions as given. Okay, and this can be calculated by using the current divider rule. So let me tell you what is the current divider rule. So in the current divider rule, if there are two resistances in parallel, and this is a total current which is dividing between the two branches I1 and I2. So the branch current is given by the total current into the resistance of the other branch divided by the total resistance. So if I need to find the value of I1, I will write which is equal to I1, that is a total current, into the resistance of the other branch, which is equal to R2, divided by the total resistance R1 plus R2. Similarly, if I want to calculate I2, which is equal to the main current, which is I, into the resistance of other branch, which is R1, divided by R1 plus R2. So this is a current divider rule. So the same thing I have applied here. Okay, so this is the branch current I2, which is equal to total current I1 into the resistance of the other branch. So resistance of the other branch is given as this is a capacitor value 0.5 F. So this I will write it as minus J by omega C. Okay, so minus J by omega C. C के value है 0.5. And this is the resistance of the other branch, and the total resistance is this. Okay, plus there is a 5 and plus there is a J omega L, that is J omega 2. L की value है 2. Okay, so just simplifying this and rearranging I2 by I1. So I have rearranged as I2 by I1. So by simplifying this and taking the LCM here, I get minus 2J divided by minus 2J plus 5 omega plus 2J omega square. Okay, so omega is given as 2 pi F. For a DC signal, the frequency is taken as 0. So omega will be equal to 0. So this term will be equal to 0 and this term will be equal to 0. Okay, so the remaining is minus 2J, okay, divided by minus 2J, so which is equal to 1. Okay, so the ratio I2 by I1 is equal to 1. This completes the numerical.